Now, some people have asked me, why do we need to do graphing? We're doing square roots. Well, graphing can be fun.
We're going to find the x and the y from the square root. So square roots are radicals?
Well, square roots are a subset of radicals. Radicals are anything with a radical sign. Square roots, cube roots, and other stuff.
All roots.
Right. Now,
Now we look at the x and square root.
if I want to look at the square root of x, so I want to graph this guy. This is where maybe you make a t-table of values. You try to figure out, well, what do I know? Just like we did a long time ago when we were coming up with the squaring function graph, or that of the absolute value. But there is something you need to know about square roots. Okay, they have a limited domain. Can you plug in anything you want to into the square root? No, you can't. Okay, because think about the square root. We already have a restriction on there. We've kind of talked about that already. We know that when I'm dealing with the square root of x, I know that my radic hand has to be greater than or equal to 0, right? Because what if I try to plug in something that's not greater than or equal to 0? If I plug in a negative number, what happens? What happens if I plug in a negative number?
Well, a lot of things happen. Depends on what the index is.
It's not a real number, but I'm talking about this guy in particular. I'm not talking about just in general. I'm talking about this specific guy. If I plug a negative value into the square root, I get something that's not a real number. So when I'm making up my t-table of values, I cannot plug in negative numbers. It's not going to make any sense. If you were to plug in -1, well, this guy is not real. What if I plug in 0? The square root of 0 is 0. If I plug in 1, what do you get? If I plug in 2, what do you get? It's about 1.414 and some other mess. It's not nice. It's what we call an irrational number. That means it can never be represented as a fraction of whole numbers. Okay, so you don't really want to plug in 2. What number would you like to plug into the square root function?
9.
Plug in 9. I'd plug in 4 first. What's the square root of 4?
2.
And then you want to plug in 9 because the square root of 9 is 3. We're graphing a function, which means it's going to pass a vertical line test, right? So plot the points that you have. 0, 0, 1, 1, 4, 2, and 9, 3. Okay. So when I connect these points, I have this shape right here. What can you tell me about the domain for this guy?
Domain is the x or y value.
The domain is the set of the x values.
Well,
Okay.
it's positive.
0 to infinity.
So it's going to be including 0 going to infinity. Do you all agree? Okay. What about your range?
0 to infinity.
It's going to be the same thing. If I look at the y values being used, the lowest I get is 0, and they go up to infinity. What do you guys think about that? Did you know that you can graph this on your graphing calculator? Okay, so let's do that. Let's look at the graphing calculator. Now to graph the square root of x, you have to see that it's right here. It's connected to your x squared button. It's a secondary feature. So like just here on the regular, just the regular home screen, I do the square root of 25. Of course, I'm going to get 5. Now you notice how with this particular version of the operating system, it puts the bar over the whole thing. If you're dealing with an older model, let me make that look better for you. So if I do the square root of 169, see how it does the square root and it opens up the parentheses? In this case, you don't have to close the parentheses since that's the only thing you have there. It's a good practice for you to do that, okay? And you see that if I go do the square root of negative 100, what should that be?
No, not imaginary.
It's not real, right? And you see it gives you an error, it says a non-real answer. Now later on I'm going to show you how you can adjust the settings in your calculator to accept that kind of input value. Okay. Now, to do higher order radicals, if you press the math button, there's a cube root function right there, and there's this guy. See, it has this little x in front, which means you can make it whatever index you want it to be. So in order to use this, you have to put the value first, like whatever you want your index to be. So if I want to do the fifth root, like I had earlier, I'd have to do 5, and then do this. So this would be the fifth root of, see, we'd mess with 1024, and the answer is 4. I don't particularly care for this. And if you go back to the other setting that we had, not the classic setting, it should actually show up as the index, and it would look the way it's supposed to look. But if we're talking about graphing, y equals, I want to do the square root, so second square root of x. So when I hit graph, there it is. I mean, it almost looks like it's a line, but this is a curve. It may be just hard to see how curved that is. Okay. Now, something that may help you out here is what this shape looks like. This guy is very similar to the parabola, right? So if you had the other half down here, it would be a parabola. And there are parabolas that are on their sides, but they're just not functions. Okay? But what's the problem with me actually connecting all of this?
That would make it negative. It's not supposed to be negative.
No. The problem with connecting all of this is that I would have something that would not be a function. It wouldn't pass the vertical line test. Right? If I give you something that's in function notation, then its graph must pass the vertical line test. Otherwise, it's not a function. Okay? Any questions about this guy?